Assalamualaikum warahmatullahi wabarakatuh and good day everyone. Welcome back to our site for CHE 433 Thermodynamics. Let's move on to our next topic which covers part 2 procedures for using steam table. For this topic, I will explain to you about basic procedure in using steam tables where you will learn how to identify different type of phase applied of water or in this subtopic known as steam. Please do note that the same procedures are applied for refrigerant 134A or better known as the R134A but using different sets of tables. We will also cover subtopics related to the application of interpolation in the steam related problem. Now, we will move to our first part where we'll cover the rules of SOP for determining phase for a given situation. The first step is for you to visualize the problem and list down the information or the clue given. A simple sketch is convenient for you to describe the problem clearly. For example, whether you are dealing with a closed or open system or when describing different thermodynamic states such as isothermal, isobaric and others. It is also helpful to describe precisely your data given and your aims in solving the problem. The next step is for you to identify whether you are dealing with a situation related to steam or R134A problems. You cannot use this rule if you are dealing with the four gas-related problems. The third step is for you to identify two properties of a concerned states. The clues or information normally available in the question, where by the time you describe the problem in the first step given earlier. And lastly, the fourth step is for you to identify your aim or objective before this will help you to chart your direction and your strategy in solving this problem. So, for this to be solved, you may refer either table A4 for a given temperature or table A5 for a given pressure. Note that both tables have the same properties depending on the availability of your data, whether you have either temperature or pressure given to you. Following this, you may identify your phase by classifying it either compressed liquid, liquid vapor, saturated vapor, or superheated steam. This procedure is crucial since if you couldn't identify correctly the phase, then you may end up getting wrong data. Now, let's take an example here where we are given a situation as such. Please read it for a while and within 2 minutes, follow the SOP that I explained to you earlier to solve this problem accordingly. Okay, in the situation given here, a rigid tank contains 50 kg of saturated liquid water at 90 degrees C. Determine the pressure in the tank and the volume of the tank. Now, let's go to the SOPs that I have explained to you earlier. By having a simple sketch, you can confirm that you are dealing with a closed system container containing 50 kg of saturated liquid water at 19 degrees C. From the statement, we can sure that we are dealing with steam related problem. So we are okay to the next step. Then you can find two properties in the problem given, which given clearly that the water is at saturated liquid and at 90 degrees C. Do note that the statement of the saturated liquid is one of the two properties that we are looking for. Then, from the situation, we know that we are looking information about the pressure and volume of the tank. From the problem given, it is clear that the only data available is the temperature, where it is at 90 degrees C, meaning we should refer to table A4 for solving the problems. Okay, before I proceed further with the solution, let's get to know about the table A4 and A5 together. This is table A4, where you will notice that the leftmost column show a column with temperature downward. Then it is followed by saturated pressure and four major columns that refers to either specific volume, internal energy, enthalpy, as well as entropy. Okay, let's see the column showing the internal energy. You will notice that here there are three sub-columns referring to a saturated liquid, evaporation, and saturated vapor. Here, the internal energy denoted with the letter U with subscript F, Fg, and G. The F refers to the internal energy of saturated liquid or fluid with the F, while G refers to the internal energy of saturated vapor or the layman term as a gas with a G. On the other hand, the Fg refers to the internal energy applied for the evaporation for that particular row of temperature. The value of Fg is basically the difference between the internal energy of saturated vapor and saturated liquid. Okay, let's give a try for this problem. Let's say I'm referring to 100 degrees C right now. Can you identify your internal energy of saturated liquid, saturated vapor, and evaporation for this temperature? Yes, we can see the value of internal energy of saturated liquid is at 419.06 kJ per kilogram and saturated vapor to be 2506 kJ per kilogram. The value of UFG here is 2087 kJ per kilogram, where if you do manual subtraction between UF and UG, you will get the same value as given. The same rule apply here for table A5, except that the leftmost column now is a list of pressure. Both information in table A4 and A5 are the same things, except that the selection of the correct table depends on the available data that you have with you right now. Now, let's coming back to the problem that we dealt earlier. We are seeking information of the pressure, volume of the closed container here. We know that we have information that the water inside the container is at 19 degrees C and at saturated liquid. Therefore, we need to refer to table A4 where at 19 degrees C, the pressure that we are looking now refer to the saturated pressure where is in this table is at 17.183 kPa. Let's say if you are given a situation that requires to find pressure but now at saturated vapor, then the pressure remains at the 17.83 kPa as the value applies for the saturated condition either in saturated liquid or in vapor. Next, to find the volume occupied by the steam inside the container, then we need to find specific volume of saturated liquid at the row of 19 degrees C. Here, we can see that the specific volume is at 0.001036 meter cubic per kilogram. Given in the question that the mass of the steam is 50 kilogram, then by a simple mathematical calculation, with the volume is simply the multiplication process between the specific volume and the mass where it gives volume to be 0.0518 meter cubic. Now, as we have mastered the SOP in finding the information from the steam table, it is also important for you to learn about the interpretation technique. The interpolation technique is needed in the case where you are looking for a data that is not directly available inside the table. For example, in the table given below, you are looking for information of saturated information temperature and specific volume of saturated vapor at 340 degrees C. If you refer to table A4, then you will realize that we do not have specifically properties at 345 degrees C. Instead, the value of 325 degrees C and 300 at 350 degrees C. So realizing that the temperature of 345 degrees C falls within the 325 and 350 degrees C, then we can determine these two properties here. Let's say we name these two data as shown here among column containing X and non value in the column containing pressure. Make sure that you do correct substitution steps accordingly. Then we can find the value to be 138.34 degrees C. Similarly, you can do the same to find specific volume with unknown value of y, where here we can find it to be 0.53177 meter cubic per kilogram. We have finally completed part 2 of this topic. In the next topic, we will learn about saturated liquid vapor region and how to determine quality accordingly. Thank you.